Okay, so here's the situation we've got here. We've got this ship cruises at 5.72 meters per second at 39 degrees east of south relative to the water, within a current that flows due southeast at 3.12 meters per second. A passenger rides a scooter along the deck at 6.83 meters per second at 53 degrees west of south. Okay, so we've got to put all that together and find, for the scooter, find the magnitude of the velocity of the scooter and the direction of the scooter relative to the shore. You know, north of east, we're going to measure, right? Okay, so what do we do here then with this? How do we deal with these problems where we've got lots of vectors that are acting simultaneously on an object? We've got to add them all up, right? Yeah, it is a chart problem, isn't it? We're going to use the method of vector resolution, which means we are going to resolve each vector into its x and y components, horizontal and vertical components, throw them in the chart, add them up, and build our resultant vector from the pieces, right? Okay, so let's take these one at a time. First of all, how about B for boat? So what's this one going to look like? Let's draw this picture. It's 5.72 is the magnitude, 39 degrees east of south. So starting at south, we're going to swing to the east. So it's going to be kind of a downward angle, isn't it? Right? So how about if we draw it like this? So there's south, right? And there's east. So I'm going to start south and swing east. Agree? So something like this, maybe. Everybody agree that's my angle? Right there, 39.0 degrees. And the magnitude is 5.72. And so we need to break that up into components. Right? So here would you agree these would be my components then? There's going to be the vertical component. There's the horizontal component, and they form a right angle. Okay, let's quickly remind ourselves about good old SOHCAHTOA. So we know SOHCAHTOA refers to a right triangle with an angle theta, right? So Brady, can you label the sides for me in this triangle? If that's my angle theta, then where's H go? Yep, right there, good. What's this one going to be? Opposite, good, and this one would be adjacent, good. And what's that mean? So means sine of theta equals, good, cosine of theta equals, good, and tangent of theta? Very good, okay, so we got that stuff, good. So then, let's break this up into components. So what's going to be the horizontal component of B? Okay, is this going to be if this is my angle, my 39-degree angle up there, is that going to be a sine or a cosine issue? What do you think, Sydney? Sine, because it deals with the opposite side, right? Remember, whenever we're resolving a vector into components, we're always taking the magnitude of the whole vector made smaller by multiplying it by either sine or cosine. So in this case, by sine, correct? So this one's going to be 5.72 sine 39 degrees, right? Okay. What about the vertical component? What's that going to be? Yeah, so that one's going to be 5.72 cosine 39 degrees, right? And we could add a row to our table. So let's go down to the bottom here. And let's table. So vector B has components, what? So we gotta pay attention to the signs of this here. So the horizontal component is 5.7 sine 39. Is it positive or negative? Is it pointing in the positive or negative x direction? Positive, right? Positive x direction is to the right, isn't it? So everybody agree? The x component is 5.72 sine 39 degrees. Is it weird that the x component has a sign in it? Well, yeah, maybe a little bit, but remember why? It's because this angle of how this angle was defined, right? The y component, positive or negative? Negative, because it's pointing down, right? We got to make it negative. 5.72 cosine 39 degrees, right? We good? Okay. So check one off the list. We took care of the boat. We took the boat's vector and resolved it into its components. Now let's look at the, what do we have next? The water. Make a little room here for the water. And the water is flowing due southeast at 3.12 meters per second. Okay, so southeast is going to be kind of starting at, well, I'm just halfway between east and south, right? So 45-degree angle, similar to this one, right? So we'll make the water vector blue, how about? I can really choose either of those angles to be 45. I'm going to pick this one right here, how about? Not that it makes a lot of difference. The magnitude was 3.12. So then Ezra, what's going to be my horizontal component of that vector? What's going to be the horizontal component of the water's velocity vector? Yeah.
That would be,
That component right there. Is it going to be a sine or a cosine issue? Say it again. Cosine, wouldn't it? So what's it going to be then? I multiply the magnitude of the whole vector by cosine 45. You got it. Okay, and the vertical component would then be right? Everybody buy that? Okay, we good? All right. Okay, yeah, this is recording. I gotta make sure. Looks like we are. Okay. Okay, so I can add these two pieces down here. 3.12 sine and cosine. So the water, oops. Water vector, the x component we said was 3.12 cosine 45. Let's make sure we got the sign right. Is the x component positive or negative? What do you think? Olivia, is it positive or negative? Positive. How come? Good. Okay. What's the y component going to be? Here's the y component, right? The y component is going negative, right? Okay. So it's going to be negative 3.12 sine 45. Okay, we good? So we got two of them down. Now all we need is the scooter. So the guy's riding his scooter at 6.83 meters per second at 53 degrees west of south. So Nathan, what's that going to look like? West of south. Where am I starting? Start there, right?
Yeah.
Which way do I swing?
To the left.
Yeah, like that, don't I? Okay. So if we draw that one then, something like this, right? So the scooter will be red, how about? So 53 degrees west of south, something kind of like that, how about? Is that the right spot?
Yeah.
Okay. This is 6.83. So when I resolve this into components, then I've got to take this thing and I've got to break it into a vertical and a horizontal. So if this is my angle, do those make sense as my components? Okay, so Nathan, what I want to know then is what's going to be, well, that's going to be hard to write there. What's going to be my horizontal component?
6.8 degree sine.
Very good. Sine because it deals with the opposite side, right? Okay, and then what is going to be the other component? Who haven't I called on? Let's see, in a while. Oh, Alyssa, what's going to be the vertical component then?
6.83 cosine.
Good, good. And cosine because if this is my angle, that the vertical component is the adjacent one, right? Very good. Okay. 6.83 cosine 53.0 degrees. Okay, and so let's make sure we get our signs correct then. So Alyssa, what's going to be the sine of the horizontal component? Positive or negative?
Negative.
Negative. Good, because it's pointing in the opposite x direction. Okay, so S for scooter, we get negative 6.83 sine 53 degrees. And how about the y component, positive or negative?
Negative.
Negative, because it points down. Negative 6.83 cosine 53 degrees. And now all we have to do is just add all that stuff up. Right, and that's just calculator work. So if I grab my calculator, okay, let's add those three up. So I've got 5.72 sine 39 plus 3.12 cosine 45, and then minus, right? I gotta subtract this one. Minus 6.83 sine 53. And that gives me a calculator answer. Now I'm just gonna write it down here as an approximation, but in reality we would probably want to just grab that on our calculator, right? So we don't risk any rounding here. So this becomes approximately 0.3512, let's say. Okay. Whoops. Let's calculate the y component. So I'm just going to go up and grab this guy, and maybe we'll have to make a few little changes. So first thing we have to do is we have to make this one negative. So I'm going to insert a negative sign. Anything else need to change on that first one? Yeah, we got to switch the sine to cosine, right? So we'll go over and change that to cosine. Next one needs to be negative also, so we'll just overwrite that plus sign with a minus sign. I gotta change the cosine to a sine. Next one is negative also, which it already is. On my calculator. Now change the sine to a cosine. And we got it. So this one is roughly negative 10.7618. Okay, well, let me grab, here are our components then, right? The product of all our labor there, what did we end up doing? We ended up finding that when we add all those vectors up, this is the overall resulting x component, and this is the overall resulting y component. So now all we have to do is just build a right triangle out of the x and y components of our resultant, and all the answers will come out of that. So let's do that. All right, so if we make our triangle. Okay, the x component's very small. Do we have to draw this to scale? No, doesn't make any difference at all, right? We just have to get the numbers up here to represent the lengths of the sides of the triangle. So the x component is positive 0.3512. So it's going to look something like that, isn't it? The y component is negative, so it goes down. The length is 10.7618. Agreed? And so would everybody agree then if I add those up tip to tail, there's our right triangle. There's the resultant. How are we going to find it? Yeah, Pythagorean theorem. Good. So we're just going to do the square root of that number squared plus that big number, and I want to put it in parentheses though, don't I? I want to go down because it's negative. Make sure I put it in parentheses. That number squared gives me, rounded to 3 sig figs is what? 10.8. Yeah. Okay, now I got to get the angle, right? Got to get the angle. So here's the angle that we've calculated, correct? I'm sorry. Yeah, that's the angle we've calculated right there. Okay, so how do we find that one? It could be a tangent issue, isn't it? We know, remember, we know from TOA that the tangent of theta equals the ratio of the opposite divided by adjacent, right? So we're going to do the inverse tangent of that ratio, okay? So we need to find this angle, the inverse tangent of, and, okay, here's something a little tricky on the calculators that I feel like I need to mention. we want, if we're trying to just find out what this angle theta is right here, we need to put these sides in as positive lengths. We're just talking about an angle in a triangle, right? When we're all done, when we know what the value of theta is, then we'll go back and interpret, okay, what does that correspond to in terms of how many degrees north of east? But first, let's just find this value. If I have a right triangle with these side lengths in this configuration, what is going to be that angle? And so what we really want to do here is we want to make those positive, okay? How do we make things positive on the calculator? There's a really easy trick for making things positive. To make any number, negative or positive, positive. Absolute value. Yeah, now how do we find an absolute value on the calculator though? It's really simple. There might even be a shortcut to it. Let me look real quick. Is there a... Well, oh, that's one way to find it, yeah. And then the way I always find it is that I just go math, whoops. Clear. I just go math, number, and it's right there. It's the first one. So enter, and I get my absolute value bars. Where'd my tangent go though? Oh, I cleared it? Oh, whoops. Okay, here's what I'll do. I'll just put that right inside there so we make it positive. How about? So now we've got a positive value to deal with. So there's the vertical component. There's the horizontal component, both being positive. So I can just go grab them. Does that make sense? We also could have just written them down. I mean, it's not that big a deal either way. I just like to have it on my calculator. So now I'll go second tangent, so inverse tangent of, I want the 10.7 blah, blah, blah number divided by the small number. And it gives me back 88.1. Okay? So this angle right here is about 88.1. All right? Okay? So if I want to know then, how far is this north of east, what I'm really trying to find is this angle right there, aren't I? Right, if I'm going to start at east and swing to the north, I've just got to keep on swinging around. How far? How would I find out what that big angle is? Yeah, it's 360 minus that would give the answer to me, wouldn't it? Right? So what is 360 minus 88.1? What do we get? 271.9. Okay, everybody agree? So let's try those. 271.9 is my angle. You got to remember this. 10.8 is my is the length of my hypotenuse. Is it weird that the hypotenuse rounded to 3 sig figs is the same as the length of the long leg rounded to 3 sig figs? How come you suppose that is? It's a little strange. Yeah, because that side's so small, right? That these two are almost the same. That's okay. That's okay, that happens. Are they actually different numbers? Sure, if we take them out far enough, they're different numbers, but rounded to 3 places, they actually round to the same 3 sig figs. Okay, so let's put these in and check ourselves.
Mr. Owen,
Yeah.
is the 271.9, is that negative or?
No, it's positive, right? Because now think in terms of like, well, for you, those of you who have had trig, think unit circle, but don't, if you haven't had trig, it's okay. If this is starting off, or we're starting the angle, how far is it all the way around in one complete circle? 360, right? And so really, we're just going to not go the complete 360. We're going to go 360 minus this 88.1. So it's positive. Yeah. Okay. I'll show you a trick though, Dean. When we put these in, it's a good question. So our final answer then looks like, if we put this stuff in, this was 12.8, right? .8, comma. You don't have to put a space, up to you. You don't need to. Probably shouldn't, actually, you don't need to. And then the last one was
71.
so, actually, we need to not, needs to be 3 sig figs, so what was it, 270? 272 then, 271.9 wasn't it?
Yeah.
So 272? Oh,
Ooh.
what the heck happened? What did we do wrong?
Is it 10.8?
Oh,
That's
10.8,
what
ah,
I was
I
like,
was like, where did
wait.
12 come from?
okay.
I was like,
Thinking, what happened there? There we go.
Yay.
Now we're ready. Okay, but, yes, sir. But 272 works, but the question was, what if you went backward? I could also do this, watch. What other number could I put in there? Yeah. How far is it north of east? Well, it's negative 88 degrees north of east because that's going backwards from north of east, right? Does that make sense? So if we're saying, in other words, if we're saying that this is the, whoa, yikes. If we're saying that, this is the positive direction we're measuring north of east, then that's just the negative direction. The opposite direction would be the negative direction. It's just like for angles, for those of you who haven't had a ton of trig, for angles, it's just like it is on a number line, right? If this is the positive, if that's 0 and that's the positive x-axis, then going backwards is the negative direction, right? So if I started here and went this way, and let's say that's 1, then that's just negative 1 because I'm going backwards. Same with angles, right? If this is positive, then that's negative. If counterclockwise is positive, clockwise becomes negative, okay? So let's try that, just to demonstrate that it works. Oops. Can't see it. Oops. Oh,
188.
did I do that wrong?
88.1.
Oh, yeah, that's right. Sig figs, good. Yes. You guys are smart, man. You're right. That's it.
No.
Huh.
just kidding.
Maybe don't do that.
Yeah.
Yeah, I guess. Don't do that.
At least you checked.
Yeah.
Sure.
Good thing to check.
It would also be a right answer,
Say it again.
but that's also a right answer.
So we
I mean, I can
Can
see
you
where,
then?
to me, it makes sense that it would be, but I guess, I don't know, I guess it's not gonna take the negative angle thing, huh? Huh, because it was 88.1, wasn't it?
Yeah.
For sure?
Uh-huh.
Huh. Not sure why it wouldn't take that, but I guess it won't. So just put in positive angles, maybe I need to add that on there, yeah. Okay. Questions, does that make sense? Okay. How are we doing here? Oh, we don't have much time. Oh, let me show you one other little trick. Give me a 1 to 5 on that. Do you feel like after having gone through that, and just let's just kind of rehearse what we did. All we did was we took each vector and broke it up into x and y components, right? And based on the direction of those components, they were either positive or negative, correct?
Right.
Okay. So our table ended up looking like that, right? Okay. We add these up, and I think it's fine. If you want to, you could just write a decimal out there. Just write it out to like 6 places, and you're fine, right? I mean, it's as long as you take it out 3 or 4 places beyond what you're going to keep in your answer. There's no way you're going to accumulate any significant rounding error. It's going to be fine. But if you want to use your calculator, go for it. So based on this picture, or excuse me, based on our components, then we constructed our right triangle that represents the resultant vector, right? We went over in the x direction, a positive small amount, that much. And we went in the negative y direction, that much, which defined our orange. The orange vector represents what's going to happen. That is our velocity vector relative to the shore, okay? To find the length, piece of cake, we're just using Pythagorean theorem. right? To find the angle, what we did was we just took all these distances as being positive, and we figured out using an inverse tangent function in this abstract triangle what that angle would be, and then we interpreted it in terms of how far would that be north of east, right? So in reality, if we started at east and we went north, how far would we have to go around until we hit that vector then, right? Which we said was all the way around 360 minus that 88.1. Okay, make sense? Okay, there is a tricky way to do this. I'm going to show you one little thing here that's kind of cool. If we were to go back and don't get confused by this. This is not anything that you have to do, nor do I even necessarily recommend you do it. I just want you to see that it does work. But if it doesn't make sense now, abandon it and we'll come back to it later in the year, okay? What if I had instead defined all three of these angles relative to due east? So instead of defining them as they were given in the directions as east of south, or southeast, or west of south, what if I had redefined all of those angles as just being north of east? If you do that, something convenient happens. So for example, this angle up here, what would it become if we defined it as just being north of east? So 39 degrees east of south would be this guy right here. So wouldn't that be, that's the same thing as saying if I start here and go around, that's going to be 270, isn't it? Because I go through 90 degrees, another 90 degrees, and another 90 degrees, right? Plus 39 would be what, 309?
320.
No, I think it'd be, so 270 plus 39, wouldn't it be 309?
Oh, yeah.
Isn't that right?
It's listen.
So 309 degrees north of east, right? Let's just take that one as an example. We could do that for all of them though. Watch what happens when we calculate these magnitudes. So what we did before, we said 5.72 sine 39 is equal to what? Somebody on your calculator, tell me what that is. Okay, 3.5997. So we'll just say out to 3.5, oh, we'll do that, 997. Fair enough, okay? What is, now compare that to.
Good afternoon, Buckaroos. It's Charla here. Mud Wars sign-ups start tomorrow.
5.72
Juniors and seniors are
sine
tomorrow only.
309
Freshmen and sophomores
degrees.
are on Wednesday. Sign up
What's that gonna do?
Sign up in groups of 1, 2, 3, or 4. And even if you're not
Same
full,
thing,
you
right?
can still go to sign up. Just make sure and let the person helping you sign up know.
Oh, hang on.
Also,
Oh,
the
no,
girls
no, no,
soccer
whoops,
team
whoops,
has
whoops,
a game
whoops, hang
at
on.
home tonight at 4 at the
Okay.
BNCC pit.
Cosine?
Pendleton
Let's see
Volleyball
how you
plays
cosine.
in
Yeah, but I can't talk
Kermison
over
tomorrow too. Good luck
This
to
is-
both teams. Good job. Go Buckaroos.
Okay, so here's the other part about it. The other part that's different is now instead of having to decide individually if they're sine or cosine, if I'm measuring the angle all the way from due east, the x component is always the cosine. There's no thinking involved. The y component is always the sine. So what we want to do instead is write this as a cosine. I'm sorry, I didn't point that out. I just want you to see this because it's pretty cool. So I guarantee that's the same thing, right? Okay. Now let's calculate the other one. 5.72 cosine 39 is going to give you what roughly? So 4.44-ish. Okay, but now calculate the y component. What if we calculated that as instead? If we calculate it as 5.72 sine 309 degrees, the whole angle. It gives you negative 4.44. So look what it does. It gives you back all of the correct signs of your components automatically. It made that one negative like it was supposed to be. You see that? It made this one positive like it was supposed to be. And it also gives you the advantage then when you're doing your calculator work. When I go back to this stage, you know, where I have to go back and grab my x component calculation and turn it into a y component calculation, I never have to worry about changing any signs. All I ever have to do is just change those 3 cosigns into 3 signs, and the calculation's done. You see what I'm saying? There's some advantages to it. So, I mean, I don't wanna, that was really quick, so I feel like I didn't cover that well, but we'll talk more about it later. But you can always do it the way we did it, right? That's fine, okay? See, did you see what I was saying there with that, though?
Yeah.